For Learning Assessment 814, the first part says use mesh equations to find V0, and we'll use our problem solving strategies entitled AC steady state analysis and loop analysis back from the previous chapter. And if you look at our circuit, we've already got two mesh equations to find, I1 and I2. So we need two equations. And we're going to now go in and apply Kirchhoff's voltage law. If you remember now, we've got a current source. And if you remember from our discussion on loop analysis, when we have a current source, and here we're using mesh in particular, we need to have a constraint equation. Okay, so our constraint equation here using mesh analysis is I2 minus I1 is equal to 2 at an angle of 90, which we could also write as J2 amps. So here's the first of our equations, and remember we need two. Now we can't apply KVL to either mesh because of the current source, but to get our other equation, what we can do is apply KVL around that loop. And if we do that, starting at the upper left and going around, we'll have 2I1, the drop across here. Here we'll have minus J2 times I2. So we come on around, we'll have 2 times I2. And if we come on around, we'll go, and that'll be equal to 24 to angle of 0. So our second equation then will be 2I1 plus 2 minus J2 I2 equal to 24 at an angle of 0. So there are our two equations. And we only need the current I2. So if we solve for I2, we'll get 4.4 plus J 3.2 amps. So now that's I2. We solved for I2 because that's what we need. Now V0 is 2I2. So we have 8.8 plus J 6.4, which is 10.88 at an angle of 36 degrees volts.